Okay, in this video, I'm going to introduce the mathematical computer modeling I use to understand the mechanics in the aortic dissection. The aortic dissection is a tear in the aortic wall. It happens when the initial defect develops on the inner layer of the aortic wall, and then the blood will flow through the defect into the wall to create a tear. Subject to blood pressure, the tear might propagate further and result in worse condition for patient. To understand the mechanical information behind the disease, we assume the process as damage failure of the aortic wall subject to blood pressure. And we decompose the big project to several aspects of the mechanical problem. Particularly, I have developed models to predict whether tear propagate or not, to find out the critical condition, and also to investigate where the tear propagates and why. Also, I developed a model to identify the effect of the tear length and depth. Because of time limitation, I can only share the last story. The motivation of this study is because the geometrical parameters of a tear are important clinical factors for the diagnosis and treatment of the aortic dissection. In this study, we consider the cross-section of the aortic wall. It includes a two-layer structure, and each layer will have different mechanical property. And then we introduce the idealized initial tear in the media. The length is characterized by the central angle eta, and the depth is measured from the inner radial surface. To simulate the blood pressure, we use this ramping pressure on both the inner radial and tear surface. Let's have a look what happened in the simulation. Subject to the pressure, both the looming and tear were invalidated firstly. As the pressure carry on increased to a certain value, the tear started to propagate. Recall that the study is going to investigate the effect of the D and eta. So to perform that process efficiently, I developed Python and Linux shell scripts with other tools to automate the process. So when the one simulation finished, I can just run one code to automatically finish the simulation with other values for D and eta. Let's have a look at the deformation pattern we have got. With a certain value for eta and D, with different value and D, I got these three. And also I'm sharing the CT scan of a patient with aortic dissection. So outside is the chest, and the aortic wall is here. If we compare the CT image with my simulation results, you can find the layer between the looming and tear are very similar. Actually, the buckling of the layer is the first time being observed in the computer modeling. And this good agreement happens for the other case. That's basically validated my computer models. But we can get more knowledge from computer modeling by applying these parameters. If you look carefully this figure, and you can find the buckling happens in this range. What is characters? Well, the D is small and the it is large. So we can conclude the long and shallow tear tends to buckling. If you want more details about this study, you can find in this paper. And remember, and please cite it as well. Okay, that's the mathematical computer modeling I would like to share you today. Thanks for your attention.